This supercomputer requires millions of watts of electricity to run, and it needs a massive cooling system just to keep from melting. Now, look at this, the human brain. It is the most powerful computer in the known universe. It can write poetry, solve physics, and feel love. And it runs on the energy equivalent of a single light bulb. For decades, Silicon Valley has tried to copy the brain, but they failed. So, scientists asked a terrifying question. Why copy the brain when we can just grow one and plug it into the machine? Welcome to Hodge Podge, where we uncover the logic behind the mystery. This is not science fiction. It is happening right now in labs like Switzerland's Final Spark and Australia's Cortical Labs. They call it Organoid Intelligence, or simply Wetware. Here's how it works. Scientists take human skin cells, reverse engineer them into stem cells, and grow them into actual living neurons. They don't build a chip like a brain. They put the brain on the chip. These are hybrid systems. Living tissue sitting on top of a multi-electrode array. The chip sends electricity to the cells, and the cells send signals back. But a clump of cells is useless unless it learns. And that leads us to the most mind-blowing experiment of the 21st century. Scientists took 800,000 lab-grown neurons, roughly the brain size of a bumblebee, and connected them to the video game Pong. But remember, these cells have no eyes. They can't see the screen. So, how do they play? It comes down to a simple universal rule. The brain hates chaos. When the cells missed the ball, the computer blasted them with unpredictable, chaotic electrical noise. It was stressful. But when they hit the ball, they received a calm, predictable signal. The neurons wanted the noise to stop. So, they rewired themselves. They physically changed their own structure to hit the ball more often. It takes a traditional AI thousands of tries to learn this game. The biological brain cells, they figured it out in 5 minutes. They weren't programmed to play. They lived the game. So, why are we doing this? Because silicon is dying. Moore's law, the idea that computers get faster and smaller every year, is hitting a physical wall. Chips are getting too hot and too expensive. Biological computing is the cheat code. These biocomputers could be 1 million times more energy efficient than current AI. Imagine a laptop that learns in real time, adapts to new problems instantly, and never needs to be charged. But this efficiency comes with a price, and a question that keeps scientists awake at night. If these cells can learn, if they can react to their environment, and if they change their structure to avoid pain and seek order, are they conscious? Some researchers call it embodied sentience. We are currently keeping these mini brains alive for a few months, but as they get bigger and smarter, at what point does the computer start to feel? Are we building the future of technology, or are we building a digital prison for living minds? This is Hodge Podge. Subscribe to discover the logic behind the mystery.